So inside the nucleus, we have what are called nucleons, and these are protons and neutrons. And when we add up how many we have of each of those, we find something called the mass number. And this is the mass number of just an individual atom. The electrons are found outside the nucleus, and in a neutral atom, the number of protons will equal the number of electrons. Now I'm using those hashtags as the stand-in for the word number. Okay, so it's not hashtag, it's just number. And then one more terminology that you should know is that the atomic number is the number of protons. And the atomic number is the large number that's on your periodic table by each element. So it might be a big blue number. In the chart in the classroom, there's a big blue number that is with each of the symbols of the elements. And that's the number of protons or the atomic number. So let's take all this information and let's apply this in practice. So we first start off with a single atom of chlorine, and it is chlorine 36. So that 36 is the mass number. So the mass number is 36. Now the proton number, you'll have to use your periodic table to find. Okay, so just write periodic table for protons. And when we look up how many protons chlorine has, we find that it is 17. Well, if we have 17 positive charges with protons, then we need to have 17 negative charges. So that atomic number tells you the number of protons and also the number of electrons. And how we get the 36, remember the mass number is the number of protons plus the number of neutrons. Remember, electrons do have a mass, but so little we ignore it. So I need to take the number 36, which is our mass number, and subtract 17 protons, and I will get 19 neutrons. So this almost completes our chart. The last thing that we need to do is write the nuclear symbol. So the nuclear symbol, the symbol of chlorine, is Cl, and I write the mass number hovering right here on the left-hand side, and then I write the atomic number or the number of protons right here in the lower left. So that is the nuclear symbol of my chlorine 36. Again, just a single atom, and these numbers represent how many protons and how many neutrons and how many electrons are in that single atom. Let's look at the next case here. So we have a mass number of 138, and we have a proton number of 56. So look at your periodic table. What is element 56? And we find that it is barium. What do you do to dead chemists? You bury them. There's your joke for the day. So this is barium-138. That, again, is the mass number. We know the proton number is 56, so we know that we should have 56 electrons. To find the neutrons, again, we take protons plus neutrons will give us 138 as my mass number. So if I have 56 protons, how many neutrons will I need to get that 138? And you're going to subtract it. So 138 minus 56, and we get, what is that? 82. So 82 neutrons. Our last thing that we need to do is write the nuclear symbol. I didn't leave myself a lot of room, but let's just scrunch it in here. So Ba is the symbol for barium, and we have a mass number of 138, and we have a proton number with 56. There is our nuclear symbol. So look in your packet. There should be a big chart where you have to do this kind of thing. So maybe stop the video and do that homework while you're looking at this to kind of guide you of how you fill that out. All right, let's look at something called the average atomic mass. So again, in a neutral atom, you're going to have the number of protons is going to equal the number of electrons. And so really what it boils down to is the atomic number, and the atomic number is this big, large number on your periodic table. That is the number of protons, and it is also the number of electrons. And as I just said before, the mass number is the protons plus the neutrons. Let's talk about something called the average atomic mass. That is this number here on your periodic table. So sometimes it might be red. Here it's just black, but this represents a weighted average of if you had a sample of this element, and we're looking at the element helium. If you had a sample of the element helium, you would find that the average mass of all the atoms in that sample would be 4.003. Again, if I have one atom, then I use the mass number. But if I'm using all of the atoms in that sample, then I'm going to use this average. And again, the average is represented on your periodic table. If you ever see something written like this, helium-4, that means we have a single atom of helium that happens to have a mass of 4. Also, if you see the nuclear symbol like this is representing just a single atom. So it's telling us the single atom has a mass of 4 and it has 2 protons. That's the atomic number. Isotopes. So isotopes, these are atoms of the same element, so they will have the same number of protons, but they'll have different numbers of neutrons. So this gives each of those atoms a different mass number. And when I look at all of a sample of an element, you will see that there will be different isotopes contained in that sample. Right here, there's a picture of the 3 different isotopes of hydrogen. When you look on the periodic table and look at the average atomic mass of hydrogen, you find that it's not 1. It's a little bit bigger than 1. And that's because of deuterium and tritium. These are isotopes of hydrogen that have neutrons. Most hydrogen only has 1 proton. That's all it has. But there are some atoms of hydrogen that they might have 1 neutron or 2 neutrons. So if they have 1 neutron, we say that it is hydrogen 2. Now remember, this number, this is the mass number. And the mass number is the number of protons plus the number of neutrons. So we can see that if we have 1 proton and 1 neutron, that gives us a mass number of 2. And looking at tritium or hydrogen 3, it has 2 neutrons and 1 proton. So when you look at all the hydrogen in a sample, you will find that most of the hydrogen in that sample will be hydrogen 1. And you can tell that because the average atomic mass of hydrogen is 1, and with just a little bit more. So that tells us that very few of the isotopes um, very these 2 isotopes, deuterium and tritium, they're not very plentiful, and so they don't contribute very much to the average mass of the hydrogen. Here are 3 isotopes of carbon, and I've written them in their nuclear symbols. So we have carbon-12, we have carbon-13, we have carbon-14. So they all have different masses and they all have different number of neutrons. However, all of them are carbon. So because they are all carbon, their proton number is always 6. So let's figure out how many neutrons each of these isotopes have. So we know that they all have 6 protons because it's carbon. Let's look at neutrons. So for neutrons, remember to get that mass number, it's protons plus neutrons. So I would just subtract 12 minus 6. I would have 6 neutrons for carbon-12. For carbon-13, I would have 7 neutrons. And for carbon-14, I would have 8 neutrons. Now, when you look at the average atomic mass of carbon, it's not just 12. It's a little bit more than that. It's 12.011. And so that's telling us that most of the isotope is carbon-12, but we do have a little bit of that carbon-13 and carbon-14, so it makes its average atomic mass be a little bit higher than 12. Let's practice calculating not only the number of protons and number of neutrons, but let's also look at how we get the average atomic mass of an element. So here we have lithium. Lithium has 2 isotopes. We have lithium-6 and lithium-7, and the mass is given to us. So we have 6 and 7. And looking on the periodic table, we find that the number of protons of lithium is 3. And because it's lithium, they both will have 3 protons. So how do we find the neutrons? Again, the protons plus the neutrons does give you that mass number. So 6 minus 3 is 3, and 7 minus 3 is 4. Now this abundance data you have to be told. So we find that in a sample of lithium, about 10% is lithium-6 and 90% is lithium-7. So let's figure out the average atomic mass of lithium. And to do this, we need to use this formula. So this formula is in your packet, but you may want to write it down in your notes. And the pattern of this is we're going to take the mass times the abundance and keep it as a percent. Don't take it out of the percent. I find that students make really stupid errors if they take it out of the percent too soon. So what we're going to do is we're going to just multiply the mass by the abundance percent, and then at the very, very end, we're going to divide by 100. Let's go ahead and work through this problem. So we have the average atomic mass of lithium would be 6 times 10% plus 7 times 90%. And then when I'm all finished, I'm going to divide by 100. So let's work this out. We have 6 times 10 is 60, plus 7 times 90 is 630. So that gives us, what is that? That is 690, and I still need to divide by 100. So we end up, when we divide that by 100, we end up getting 6.90. So now if you look at the average atomic mass of lithium on the periodic table, we did pretty good here. So we probably have a little bit of rounding with the 10% and the 90%, but this is just to give you a good idea of how you work these out. So again, you want to save and take it out of percent at the last minute. I just find that if I tell students that there's 5% of one element, or excuse me, of one isotope, they will write that percentage as 0.5, not 0.05. So just to avoid all those common errors, keep it in a percent and at the very end, then divide it by 100. This is how you figure out the average atomic mass. And if you do have more than just 2 isotopes, then you would just keep going and add on. And then again, divide by 100 at the end.